Okay, welcome. It's February 17th, and this is a Lesson 5 help session. What I'd like to do first is do a little demo and talk about change detection. Now, although this demo, we're going to use imagery, it's important to keep in mind that the principles we're going to cover here are very similar to what you may want to consider doing for your assignment. There's dozens of different ways you can approach this assignment. Some you can accomplish an awful lot in a few rules. Other times you may want to use a lot of different algorithms. Both ways are going to be successful. Okay, so one of the things I've got here in this particular case, if I go to my project, you're going to notice that I have two sets of data. One is actually 8-bit National Agricultural Imagery Program aerial data, and the other is QuickBird satellite imagery. These are different resolutions, and one of the real strengths of object-based approaches to change detection, especially with high-resolution data, is that we don't have to resample the data and worry about precise pixel-to-pixel alignment. And this is because some of the offset issues, the resolution issues, can get ameliorated by the object. Now, if we've got major shifts in our data, an object-based approach isn't going to solve it. But if we just have minor shifts, we can really deal with those very, very well when we start working at the object level as opposed to the pixel level. Okay, so we've got both those data sets, Washington, D.C. area. You can see here we've really got some major change that's happening. And then we've got things that are probably just a factor of the phenology, different wetness conditions. You can see some of these grassy areas appear very different between the two time periods, likely just because of when it rained last. So I'm going to take a look at two different methods of change detection. These are really simple. These are sort of first pass type change detections. No way would I consider this to be a complete project, but I think it'll give you enough to go on. So let's take a look at this first one. In this first one, we do what I call object differencing. So the first thing I'm going to do is run a segmentation here. We'll go and take a look at the segmentation settings afterwards. You can see my scale parameter here, probably a little bit or quite a bit higher than something you'd normally see, but we're looking for very large changes on the landscape here, and that's why I'm focused at using these much larger objects. So, and then after that, really what we do is we look at the difference in NDVI between the two time periods. So here you can see that I actually started off segmenting, and I used all of my input data sets to segment, okay? And then my classification rule simply says two things. It says if the NDVI difference between 2011 and 2006 is really low, and if the NDVI in 2011 is low, then we're assigning you to the vegetation remove category. So let's back up here and take a look at my customized features, because my customized features are very important here. So first I computed the NDVI for both 2011 and 2006, okay? And then I took the difference in the NDVI between those two time periods. So I created two customized features and then used those customized features in another customized feature. All right, you may want to do this with your homework assignment. Of course, instead of NDVI, you may be using your LiDAR surface models for that. Once we have that, we can click on some of these areas where vegetation has been removed. We can see that the NDVI difference is very high, but we also see in other areas, like some of these fields here, the NDVI difference is quite high as well. And so that's why I also included the NDVI from 2011. So we go ahead and click execute here. And once again, this is not a perfect classification. It's a simple first cut, but we do a really nice job identifying those areas where changes have occurred between the two time periods. Okay, so it's just some simple object differencing. Let's go ahead and reset here. Next time, what I'm going to do in this particular instance, if you take a look at the segmentation algorithm, I'm going to only segment on the 2006 data. Okay, so 2006 is going to be my starting point in this case, and then you're going to see we're going to build off of that. Okay, so first we're going to classify vegetation, and then we're going to reclassify that vegetation if we think it has changed over time. We can accomplish a very similar end state. We're just going from a different starting point. So here we go. Let's expand this. First rule we have, which said if you're unclassified and your NDVI in 2006 is greater than 0.5, we're going to call you vegetation in 2006. Okay, so you can see that there. Next rule, we say if your vegetation in 2006 and your NDVI in 2011 is below 0.03, we're going to assign you with vegetation removed. Okay, and then we go to vegetation unclassified, right? And so there we can see how we focused on that particular approach, right? We started off with those features, and then we looked at features that had changed. So different ways of doing it, and you may want to use one of these approaches for your homework assignment, or you may want to integrate these approaches. And as you can see here, we definitely want to do some refinement after this. We'd want to bring in some context, if you're an object and you're really close to one of these objects that have changed, you may have changed, and so forth. But I hope this gives you a simple framework from which to start your assignment if you've been struggling up to this point in time. So that being said, we'll pause there and take any questions that folks may have.
I just had a question about getting the two different screens. So I understand how to do horizontal or vertical. I absolutely understand that. And I understand that on the first mode, or view one, that's where you add the different maps. I guess my biggest issue was, do I have to add those separately? So if I'm adding the 2008 and then I'm adding the 2010 DSM or the DEM, I have to create it there so I can see it on view 3, correct?
So let's back up here. First and foremost, when you go to modify open project, when you create your project, it should only have the layers specified in the assignment. That is absolutely crucial. If you add in extra layers, like if you create additional LiDAR surface models that you find useful and you load them in, your rule set will fail on my end, and that's where I spend most of my time on grading. Those can take over an hour to sort out. So
Yes.
just make sure that's done first of all. When you have those layers loaded, you can open up, your view settings, this little thing here. And so I typically like to do a split vertically or split horizontally. I also like to do a side-by-side view. That makes sure that things are synced together. And then I can choose, you can see here in my view settings, if I click in that view, I can change which data set appears in which view. I can click in this one, right, and change it there. Click in this one, right? Maybe I want to make this a true color based on 2006. There we go. Does that answer your question?
That does. I was creating multiple maps in view 1 to be able to select them up on that the top bar. I wasn't going to that view setting. So yes, that makes perfect sense. Your way is way better.
Yeah, it's really simple. Yep, just changing those view settings. Incidentally, if you're interested, you can go ahead and even do this in your rule set. So just to show you something this is handy if you find yourself needing to change your view settings all the time. And I always have to look at where this is. So bear with me here. Interactive options. Save, restore. Oh yeah, define the view layout. Yep. So there's define view layout, and you can say split vertically. Okay, so then it'll do that. And then if you look within here, I can change this to side-by-side view. So then it links them. And then you can even, there's algorithms here. Let's see, set custom view settings. Yes, that's the one. And so now you can say pane, apply to my first pane. I've got 2 here. And then I can go and I can actually change the layers that show up here. So I can do to my image layer mixing, set the image layer mixing for that particular pane. So then I can do that, of course, providing I did that, then I could go ahead and then I could do that for my second pane. And this can be handy because when you do this in the rule set, you can have that up first in a step called like prep view settings, and you just run it and it sets the view like you want it. So eCognition offers a lot of nice automation like that. It's kind of challenging because every time they do a new release, there's usually some cool new algorithms in here that you've got to scroll through and decide, do these relate to me? But this is one, if you're playing around with your view settings a lot, this can be quite handy.
So because it's in a rule, if you gave that to somebody else, they would automatically set theirs up to view it the way you've been viewing it, correct?
Exactly, yeah. So you can set it
Oh,
up. So
okay.
maybe the imagery's in one and your LiDAR surface model's in another, right? Or changing the stretch type. I just find it handy because oftentimes when I'm working on a large data set, I'll be going to all these different subsets that I'm working on, and I don't want to have to manually click through this every time. This allows me to just update my view settings in a completely automated fashion, but also handy once again if you pass your rule set along to someone else.
Makes sense. Thank you so much.
Great, thanks. Good question, Luke. Other questions, folks?
Hi, this is Zach Jones.
Yeah, Zach.
Quick question on the creation of the digital terrain models. I know that came up in the discussion forums. In the directions in the assignment, say to go with the last return in
Yeah.
terms of the model. I was going off of following the model with the DSM in the level 2 in the lesson 2 video, and doing last return plus last of last returns.
Yep.
I was just a little concerned. It looked diagnostic and it looked like it was an effective model, but I was just a little concerned with if you went with something different, the e-cognition models running differently.
Yeah. So if you do something strange with your surface models, indeed it will. As long as you follow the recommendations in the assignment, you'll be good. And even if you choose, sometimes there's those minor switches between ArcGIS, even those don't differ. The key thing is, of course, that you should understand your data, right? And so buildings should look very similar between a DSM, and what we're calling the DTM. So between first and last returns, buildings should be identical. Trees, of course, should be very different in that situation because they have multiple returns. And that's what we're getting at here. In this class, we don't have you go in and actually make full use of the point cloud. That's something you can do in eCognition. It just adds a little bit of complexity, so the surface models keep it simple. But as long as when you're looking at your data, you see those key differences, that's a good sign that you're on the right path to creating those surface models. One thing that did come up in the forum is someone was just accepting all the default settings, right? And so please make sure you go back and look at those lesson 2 videos, right? You spent time doing this in lab 2 where you worked through like, hey, what should my cell size be, right? And give that some thought. And obviously when I take your rule set, I may not have the exact same cell size, but as long as we're in the proximity and it's based on the statistics of LiDAR data, you're going to be good. If you just randomly chose 30 meters as the size or 30 feet as the size for your LiDAR surface models, then you're going to see issues when I run it. Does that answer your question?
Yeah, that helps. Thank you.
Okay, great. Other ones?
Hey, this is Jeremy.
Oh, hi,
Can
Jeremy.
you, this is related to what Luke was talking about. Can you go to the little, I guess it's the workspace window next to the little I button?
So workspace is view 1. Is that what you mean?
No, go over to your right where the little info button is, or the I, the letter I.
Oh, the letter
Keep
I. That's
going.
that's the image object information one.
Okay, so the icon to the left of that.
This one here.
Yes, yes.
Yeah, that's view 1. So if you switch to view 1, you'll see your workspace as well.
Okay, so where is, I guess, the name of the image that's showing in when you go to view 1?
So you're confusing things. So your workspace is a container for one or more projects. You want to go to view settings, right? In view
Okay.
settings, you can see the data that's loaded, right? So let's say I want to display true color for 2011. Click in here and make that change. Click over here. You can see the orange highlight, and I want to make that true color for 2006. Then I do that. Does that help you out?
Well, I guess what had happened was that I thought I was looking at the ortho image, and then now it says I'm looking at one of my DEMs, and I don't know if I changed that.
So your view settings control what you see displayed. So make sure you open your view settings, which is this little eye here.
Mhm.
Okay, and that controls what you're seeing in the viewer. Now keep in mind your object cuts through all your layers and retrieves information from all of them. So what you have displayed in the view has no bearing on your rule set. It just helps you design your rule set.
Okay. Yeah, because I basically created a new workspace and I started fresh just to check myself, and I noticed that when I was in view 1, I was seeing ortho versus the DEM when
That's just entirely due to your view settings. Yeah, there's almost never a need to recreate a workspace or a project, and almost never a need to start from scratch because it's just a rule set, right? You're just coding. You can add, move, delete algorithms, and of course you can even turn on and off algorithms, right? Like if I don't want this to run, I can just disable it. Those square brackets go around it. I can do a breakpoint which stops it there, but the square brackets will disable this, and so it'll just ignore it when it runs.
So if you click back on that little icon to the left of the info button,
that's for your workspace. So if you're so this one here is for managing your workspace. That's for when you do subsets. So go back to the early parts of lesson 3 and watch the workspace and project settings. So if I needed to do a subset, then I'd go back to my workspace. For viewing the data, you do not go back to your workspace for that. That should be done in the view settings. Your workspace really should just be for subsets, creating new projects and subsets. All of your viewing should be done here.
Okay.
In the view settings.
That helps.
Yeah, and go back and watch that projects and workspaces video.
In 3.
Refresher.
Thank you.
Sure thing. Good questions, though. Anything else, folks?
I had a question regarding the thematic layers, the vector layers.
Yep.
Are you able to? So I've dropped the subject parcels into my project. And what I was hoping to do...
If you do that, your rule set will fail to run on my end. So what's really crucial, I know this is a little bit of a pain, but the only way I can get all of your rule sets to run is that if we have standards and specifications. So if you are doing that, you want to do that for your final project in this class, great. If you're doing that right now, your rule set fails because it will...
Okay, so I'll remove it.
Yeah, make sure...
But I still have a question.
Yeah, make sure you're not making use of it. And this is a case where, so you can make use of vector data in eCognition, which is what's really cool. So quite like I've got a project right now, and I'm doing tree canopy, and I've got a buildings layer, and that buildings layer is like 99% accurate. So I'm definitely using it because it helps me differentiate true tree canopy from other things that are tall. I've only got 3-band imagery, but I've got good LiDAR data. So that's an example of where I'll make use of vector data. We don't cover that a lot, but if we want to do a help session prior to your final project, especially if you think vector data will assist you in this particular project, what I recommend is that once you've identified those buildings, when it comes down to figuring out what parcels are affected, really that's a chance to just use your basic GIS skills. And just one of the things, we want to do in this class is push you back to say, once you've done remote sensing work, feature extraction, I don't care if you're using Imagine, I don't care if you're using an online deep learning program, I don't care if you're using TensorFlow, eCognition, you're probably going to come back into a GIS software. So when you get your points out, really we're saying here, can you remember some of your basic GIS overlay skills? And for some of you, this will be really easy. And for some of you that have forgotten Intro to GIS, it might be a little bit more difficult. But can you remember your basic GIS overlay skills to figure out which properties are actually affected by building removals, or which properties had buildings removed? Does that make sense?
Yeah, absolutely. I was just wondering if you could combine these things, because I tried a Boolean operation to combine them as I'm just playing around with it, so that I could essentially export a point shape file with all the attribute information for those specific parcels.
Yeah, you absolutely can.
Yeah,
you absolutely can. I would still say that's an operation that's better handled in GIS software. Simply because that's what it's designed for. But eCognition does have a whole set of vector operations that do allow for these type of things. But once again, it's one of those things that's just, and realistically, if you were doing this right, you'd be doing QA, QC on those points. So you'd be bringing them into ArcGIS or QGIS and probably deleting ones that were false positives, right? This is an example where if I was doing this for real, which we did, we overshot the building demolition category because we had technicians go through and then delete those points. We didn't want to have any errors of omission because it's very, very hard to find those, right? But they just went to, a few hundred points in the city, just checked them all, deleted, I think 3% that were false, and then we went from there.
Okay.
Yeah.
Well, thank you.
Sure, no problem. And like I said, if you're very interested in using vector layers, happy to set up a help session on that for our final projects. Any other questions?
Okay, thank you.
Sorry, I missed a little bit of the last answer there, Jarlath. I was in a panic looking at the shapefile data because I haven't looked at it yet during my workflow. But kind of what I was gathering from your comments was that the parcels shapefile data is more for visualization of the final map and
Well,
should
it's for
not be
visualization.
included.
There is some. So one of the things that the goal to show in the final map is what parcels are affected, what parcels contain those. So that's a very, very simple, right? And depending on your work experience, for some people, this is like a split second. I know that tool. For others of you, you may have to go back and revisit your Intro to GIS coursework and be like, if I've got points and I've got polygons, how do I find those polygons that contain those points? How do I highlight those parcels so I can show it in a map to make it clear which properties the inspectors need to go to? Does that make sense?
Yeah, thanks.
Okay, great. All right. Hey, folks, thanks for joining tonight. As always, really good questions. I'll work on getting this recording up. I think people really benefit from it.